All right, so as you can see, we're looking at the Unit 1 test preview with this video, getting you ready for your Unit 1 test. To give you a really good idea of what's on the Unit 1 test, you can ask yourself the essential questions that we started with at the beginning of this unit and that we've looked at as we've gone through this unit so far this year. Number one was, how can we use algebra to represent real-life situations? That's where I'm expecting some word problems or some story problems and using variables to represent unknowns in certain situations. Number two says, how do we use what we know about numbers and variables to simplify expressions? Keeping in mind that variables just stand for some unknown number. How can we use those rules to simplify expressions, either involving multiplication or combining like terms or the distributive property? And then, of course, the biggie, how do I solve algebraic equations, proportions, and inequalities? Those three main types of problems that we've solved with those same basic steps from your background knowledge. On the test, what you should look for on this Unit 1 test is basically 5 types of problems. We'll be writing variable expressions and equations, which I'll give you an example of, as well as simplifying expressions. Again, maybe it's distributive property or combining like terms or even some multiplication or exponent rules. Solving equations and proportions, solving and graphing inequalities where we have a number line and we have an infinite number of solutions. And then, of course, writing and solving equations, either just solving regular equations or even writing and solving equations with the word problem. For the first example, then, let's look at the idea of writing variable expressions and equations. It says write this as a variable expression. You'll have to do this as well as with an equation. In this case, it's not a sentence, it's just a phrase. I just need an expression for the difference of 15 and the quotient of 2 and x. And so there's a lot of keywords that we see in here as far as difference. We see 15, then we know we're going to have some sort of involvement there. We see quotient, which makes me think division. Also makes me think that order matters in quotient and in difference. When I read those words, the order matters. I see a number 2, and then of course I see x. Remember, when we're writing these expressions or equations, the first thing I'm always going to want to write down on my paper is the variable, and then build from there. When I read the difference of 15 and the quotient of 2 and x, I see that the next thing that I would work with x is the quotient of 2 and x, which really means we're going to divide 2 and x. And because order matters, we need 2 divided by x. So in this case, I would have x on the bottom of my fraction and 2 on the top. That's the quotient of 2 and x. But I want the difference of 15 and 2 divided by x. And so notice again, because we see difference, we know that order matters in subtraction. And so because the 15 came first in the problem, the 15 needs to come first in my expression. And so my final answer ends up being 15 minus 2 divided by x when I go to write this as an expression. Again, on the test, you might see equations where we have an equal sign. You might also just see expressions like this. That'd be the first type of problem that you'll see on the test on Thursday. The second type of problem is where we simplify. Here you see kind of a big fancy distributive property problem. We got to remember some of the order of operations rules that we've talked about. Because we see brackets, we have to start there first. And then we know we start on the inside most. So in this case, we'd have to start by distributing this 2 to everything inside here. And so that would leave me with 3 times the quantity of 5 plus 2 times 5x, which is 10x, and 2 times the negative 2y, which is a negative 4y. That's all still in brackets, and so again, I would see that I'm going to be using the distributive property again. 3 times 5 is 15. 3 times 10x would be 30x, and then of course that'd be minus 12y. Wouldn't want to leave my answer like this. I want to get it back written the way that we prefer it, with the variables out in front in alphabetical order. So I'd have 30x minus 12y plus 15. That gives you just a little bit of a taste of the kind of expressions that you'll have to simplify on your test on Thursday. Next type of problem that you see is just solving for x. You're not going to see them all looking like this, but just wanted to give you this generic example to give you the basic idea of what we're trying to do when we solve for x. Using your background knowledge, what's your goal when solving for x, and what do we use, and what's our main rule of algebra as far as, whatever we do to one side, we must do to the other side. So in this case, if I see that x is by itself, I might use the cover-up method and cover up that ax, that term, and I see that the thing that's keeping x from being by itself, first off, is b, and I'm adding b over here right now. So in order to get rid of adding b, I would just subtract by b. Again, variables just stand for unknown numbers. We can use those same rules, but whatever we do to one side, we must do to the other. That takes care of the b's on the left, but that leaves you with ax equals whatever c minus b is. And because those are variables that we can't combine, we don't know what those are, and so we'd have to just leave it as c minus b. And so we see that a times x equals c minus b, and now I'm trying to decide, well, how would I get x by itself now? You have a times x, so in order to get rid of that multiplication, we'd have to divide by a. If we do that on the left, of course, though, we have to do it on the right. That gets x all by itself, and then I'm left with an algebraic expression of its own over here, which would be c minus b all divided by a. If we actually knew those numbers, we'd know what our answer is, but for now, that's as good as it gets. Just really going over those basic ideas of how to solve any given equation. The last type of regular problem that you'll see without the word problems or story problems is just solving and graphing inequalities. Again, those same basic rules apply as far as trying to isolate the variable on one side of the equation, or in this case inequality, and then whatever we do to one side we know we must do to the other side. The other biggie with the inequalities that this example shows is when I divide by a negative, or when I divide or multiply by a negative on either side, I have to flip the arrow. So this becomes 2 is greater than or equal to x. When I go to graph this, remember we've talked about the idea of flipping these. When I do that, I also need to flip the arrow. This would be x is less than or equal to 2. I find that boundary line on the number line. Because it's less than or equal to, I see that I can use a closed dot to mark that point, and values less than 2 would be to the left, and that takes care of that inequality problem. The last type of problems that you'll see on your test are word problems or story problems. You see this one here. It says to write and solve an equation to find the missing value. In this case, it says a rectangle is twice as long as it is wide. It has a perimeter of 84 centimeters. What is the rectangle's width? And remember, that question is one of the more important things that we see as far as, well, what is our unknown? And in this case, the width is the unknown. It also gives us some information as far as twice as long as it is wide. Big thinking strategy here would be to visualize by drawing a picture. I definitely want to get this idea down on paper so I can picture this idea. My two unknowns would be the length and the width, but I see by this sentence that it's twice as long as it is wide. That helps me know that if I had the width of W, I would have a length of 2W. The other important piece of information in this scenario is that it gives us the perimeter. And so I think to myself, well, how would I find the perimeter? And in this case, I know that I would add up all those sides. So I would have 2W plus W plus 2W plus W. And when I add those all up, I'd see that I really have 6W is equal to 84 centimeters. That's a one-step simple equation to solve. If I divide by 6 on the left, I have to divide by 6 on the right. And then I see that my W here in this case would equal 14 centimeters with my label. Then I go back to my question and I say, well, have I answered the question? Did it ask for just the width or also the length? And in this case, it is just the width. Again, a very quick overview as far as what to expect on your test. 5 main types of problems: writing variable expressions and equations, simplifying expressions, solving equations and proportions, solving and graphing inequalities, and writing and solving equations. If you need any help before Thursday, come in and see me during Walk to Learn or ask questions during class.